I lost a game of filler. I needed to make sure this never happens again, so I made this. My Game Pigeon Filler AI Stockfish Solver program that will make me win every single time. Some of you may not even know what filler is, so let me explain. Filler is a Game Pigeon game that you send to your friends when you want to play a strategy game, but your friend is too dumb to play chess. So you give them a game full of fun colors to stimulate their Cocomelon infused brain. Each turn, either player gets to choose between 6 colors to convert to. However, you cannot choose your own color or choose your opponent's color, therefore only giving you 4 colors to choose from. When you transform, all of the same colors next to your corner will then join you and become part of you. The goal is to spread across the board until there are no more colors to capture, the winning player being the one with the most tiles at the end of the game. The algorithm that I used to make this engine is the minimax algorithm. Specifically, I used the alpha beta pruning version of the minimax algorithm, but that is a bit more complex than I want to get into, and it really just is a faster version of the algorithm that I will show. In order to understand what the minimax algorithm is doing, we first have to understand how I am evaluating a score. The score is calculated by taking the amount of squares that you have minus the amount of squares that the AI had, and then that will be the score value. This means that if you have a positive score, you have more squares than your opponent, meaning you are winning. If you have a negative score, that means your opponent has more squares than you, and that means you are losing. And if you have a score of 0, that means it is a tie currently, and you have the same amount of squares as your opponent does. Now here's the algorithm. To start, here's our board. We are going to represent it with a node. From that position, we get 4 possible moves, and if we do one of those moves, our opponent also has 4 moves that they can do. So here we have a tree representing every single state that the game could be in 2 moves deep. Now at every single one of these bottom nodes, I'm going to write the score associated with that position. Now that we have this, we can establish who our maximizing player is and our minimizing player is. The maximizing player wants to increase the score, and the minimizer player wants to decrease the score. Let's first start with the bottom of the tree, which is our minimizer. The minimizer wants to select the lowest value at every single branch. So in this example, -1 is our lowest value for the first branch. 0 is the lowest value for the second branch. -2 is the lowest value for the third branch, and 0 is the lowest value for our last branch. Now lastly, it is the maximizer's turn. So now they will choose the maximum value, which is 0, and then the 0 will move up to the top. That will be the best score if both players play perfectly, up to 2 moves. In this example, the player will play blue and the opponent will play yellow. As you look further down the tree, there are more and more possible states, meaning our tree is growing exponentially. This makes the program kind of slow when it gets to more moves that I want to calculate, but I did find it is decently fast at 10 to 12 moves deep, which is enough that I have not been able to beat it yet. But I also could just be really bad. Maybe if you're good at filler, you could beat it at 10 to 12 moves deep, but I have a hard time believing you'd be able to beat it if it was like 18 moves deep. However, it would also take a couple hours to do that because I'm not the best programmer, and I'm sure there was better ways to optimize this program than what I have done. But just for fun, I'm going to test this program so you guys can see it in action. Also, I added an evaluation bar which shows which player is currently winning in the mind of the AI. Okay, so this first game I'm playing against the AI, this is at a depth of 12, so it's looking 12 moves ahead, and you can see it did beat me. It's kind of annoying the way it plays. It tends to block the move that I want to do, and it did that quite a bit this game. Okay, so now this is 2 AIs fighting each other. They both can see 12 moves deep, and you can quickly see that one side is at an advantage, and the game cuts short because of the way I set up the code, but the green side did win. In my mind, when I first made this program, I had a feeling that all games would be a tie with the best play, but that's just not true. The reason this isn't true is because of the board generation. Each board is random, so sometimes one side will be luckier in what the board gives them versus the other side. Okay, now for the last test, I'm going to be fighting my AI against an AI I found online on this website, made by the person It's As Shrimple As That. Not much interesting about this game, but we did end up winning. Their AI says it can see 20 moves deep, and mine was running at 12 moves deep. So you would think that theirs would win. I think that seeing 12 moves deep versus 20 moves deep isn't changing that much. I feel like the majority of the game is kind of luck based on how good of a board you got if you were able to play 12 moves or 20 moves deep. Alright, so this is the end of the video. If you did like it, I really would appreciate some support in whatever way you want to do it. This video did take me a lot of time to code and to edit. Also, my code can be available if that is wanted. I'm thinking if this video gets like a decent amount of reception, I will make my code available. It's not good, so that's why I'm not making it available right away. I kind of want some time to go back and edit some of it to make it more user-friendly, or at least just clean it up so it's easier to read. That way you guys can run this engine and use this to play filler yourself against it, or use it against your friends. Alright, that's all. Thank you guys.